Okay, let's give you guys some practice. So work out the surface area of this circle being rotated 360 along the x-axis. So when you rotate it 360 along the x-axis, you will trace out a donut-like shape. Well, work out the surface area of that donut-like shape. So you've been given these parametric equations here. When time equals 0, if you put 0 into here, the x-coordinate will be 1. So 1 across. If you when time equals 0, if you put 0 into here, then the y-coordinate will be 2. So this is your starting position. When time equals 0, this is your starting position. If you keep on increasing t, the particle will move around like this. And then we're going to revolve this 360 along the x-axis. So we'll trace out a donut-like shape. We'll work out the surface area of that donut-like shape. And as a clue, this is your clue. If you don't recognize this, then track back to one of the earlier videos. Okay, so this is your clue here. Work out the surface area. So press pause and have a go. Okay, so to do this, the way you should read this is that a small change in time would result. So a small change in time, when you combine it with this, it will result in a small change in the distance of the actual path. So let's start again. A small change in time would result in a small change in the distance of the actual path. So when you start out with a small change in time, combine it with this, and it will represent the distance here from here to here. So this is your ds. So once you've got your ds, you will need to times it with you will need to times it 300. You will need to times it with the circumference of the circle. So 2 pi r. Well, this r here, the radius here, is really this bit here, because as you're moving around, the height here, which is your 2 pi r, which is your r, the height is given by, well, it's given by this. So as you're moving around, that's the height here, and then from here, that's the height here, that's the height here. So this bit is really your radius. So let's start again. A small change in time would result in a small change in the distance of the actual path. So combining with this represents this bit here represents your ds. Once you've got your ds, you will need to times it with the circumference of the circle, which is 2 pi r, but r in this case is this bit here. So once you've got your ds, so let's start again. A small change in time would result in a small change in the distance of the actual path. Once you've got your ds, remember ds is this thing here, times it with 2 pi r, which is this bit here, and then this dA here represents a small change in the area of this strip. Hang on. So this is your area here. Okay, so once you've got your small change in the area, you will need to sum up all the areas as you're moving around here. So you've got another one here. As you're moving around here, you will need to times it with 2 pi r, and then as you're moving around here, you will need to times it with 2 pi r. Even when you're over here, you still need to times it with 2 pi r, and then over here you still need to times it with 2 pi r. So basically, a small change in the actual path, well, you need to times it with 2 pi r. This is your r here. So the dA here represents this, but then you will need to sum up all the dAs. So you will need to sum up all the dAs. So the surface area is given by this. Remember, you are integrating with respect to time. So if you look back at this, you got to decide on your limits. So all the way around here, remember you're integrating with respect to time. So all the way around here would mean a time starting from 0 to a time of 2 pi. So when time starts at 0, it's here. When time gets to 2 pi, it does one complete revolution. So really your integral is from 0 to 2 pi, because you're doing it with respect to time here. Well, anyway, the surface area is given by this. Now, looking at the formula here, in order for you to calculate the surface area, you would need to work out dx by dt, and you would need to work out dy by dt. So looking at the original parametric equations, we would need to work out dx by dt. Well, dx by dt is given by you differentiating it. And then dy by dt would be you differentiating it. That will then give you this. So now we can put this into here, and then we can put this into here, and then don't forget we've got to square it. So this whole thing here will then become this. Will then become this. So when you square this, well, this whole thing here is actually 1. So that will mean this is 1. So you're just left with this. So now integrate it. It will then give you this, and then it's blah blah blah, giving you the answer of 8 pi squared. So that's your surface area. Okay.